Hey Compact students, this is Miss Moyer from 7-1. This video is on rotations, section 11.4. So we've got two images rotating on our screen. We've got the key and the pencil. Think for a minute, which of those is rotating clockwise? Yeah, the key is going clockwise. The pencil is rotating counterclockwise. And I have some definitions down here that show the numbers from a clock and show you what it looks like clockwise, counterclockwise. These are words that I expect you've probably seen and should know, but just as a reminder, they're pretty important in rotations. Okay, we're in your notes, page 8. A rotation or turn is a transformation in which a figure is rotated about a point called the center of rotation. And that's shown in our picture here. This point that I'm just coloring in red is called the center of rotation. The number of degrees a figure rotates is called the angle of rotation. And that's shown here in our picture from the red to the blue figure. That is a 90-degree rotation. Think for a sec, is it clockwise or counterclockwise? It is clockwise, the same way as the hands on the clock. When we do a rotation, the original figure and its image are congruent. Maybe rotated around. Remember, congruent means same shape, same size. When it comes to rotating in the coordinate plane, things get kind of complicated. So let's work through this one a little slowly. We've got this trapezoid here, WXYZ. It's already drawn on your graph. And we are being asked to rotate the trapezoid 180 degrees about the origin, so about these directions. First, they didn't tell us clockwise or counterclockwise. Think about 180 degrees. If I have a 180-degree angle, it's a straight line. So if I go 180 this way, clockwise, or 180 that way, counterclockwise, I end up in the same place. So it does not matter if you say clockwise or counterclockwise. So 180 degrees, and then the next part about the origin. That means the origin is your center of rotation. And essentially your figure is going to be, it's like it's attached by a pole and it can't move from that distance. So as we rotate this around, it's always going to be, Z is always going to be that far away from the origin. If I rotated the line between the origin and Z 90 degrees to the right, it will end up over here in quadrant 1. And that's only a 90-degree rotation. If I keep going and rotate another 90 degrees, that's the same as a 180-degree rotation. You'll notice that that line from Z here, from Z down here to the origin, keeps going. It's just a straight line. I wanted to just point out before I erase all of these lines, or all the extra lines, that the distance from Z to the origin has to be the same every rotation you make. So notice that from the origin to original point, Z is up 2 over 1. Then if we were rotating at 90 degrees, it's over 2 up 1. And to go down to the other rotation here, that's also a ratio of 2 and 1. So those, when you're trying to figure out where to put the next point, the steps there can be helpful, that ratio. So now our line is showing us where Z prime should go. Our image of Z is right there, the same distance from the origin, but 180 degrees rotated from point Z. The similar stuff's going to happen with the other points, and we could keep drawing all these lines. So I could draw from W to the origin, and then that same line continuing out would go over there, and we would end up with W prime out here. And and continue and continue, hopefully after a little while you start to see how this works and can get oriented as to what the drawing looks like. So we've got, so that'll be over 3, down 4. So it's going to end up over here, right? So notice what I was doing there. So that's going to give me x prime. And if I start sketching in this shape, you might realize where that last point has to go to make it congruent to the original figure. It's a great strategy to make this go a little faster. So our final image is going to be at 4, -2. X prime is at 3, -4. Y prime is at 1, -4. Z prime at 1, -2. I wanted to quick show an alternative way of figuring out where an image goes for a transformation. So here I've got a picture of the same trapezoid. And if I were on a piece of paper, I would take that paper and rotate it 180 degrees like it's asking me for in the video. So this is where maybe some scratch paper off to the side is what you'd use. And I would make a sketch. And you'll notice that where this ends up, I'm seeing that's X, that's Y, Z goes up here, W goes up here. These are all the images. My trapezoid will look like this. And I see that even when I rotate this, if I'm rotating about the origin, I even can get the points. So if this really were the top of the graph, for example, point Z prime will be at 1, -2. And W prime would be at 4, -2. And so you can do this even and get all the points, not just the sketch, but the points, and then use that to plot the new image. Okay, example 3. First step, draw the triangle JKL as shown in the directions. Pause it and draw your triangle. Okay, so now we've got our triangle drawn. Check. So we have to figure out what this rotate 90 degrees counterclockwise about vertex L means. So about vertex L, that's new. What that's telling us is that vertex L is the center of rotation. And in essence, for this, we're going to need to put an imaginary push pin into point L. So I sketched in that imaginary push pin because L is stuck. That is the center of rotation. It's like the hub of the wheel. And what that means is L prime is going to end up in exactly the same place as L. And then step 2 says to plot J prime so that JL and segment J prime L prime are congruent and form a 90-degree angle. So what that means is we need to think about 90-degree angle, and it's 90 degrees counterclockwise. So I'm going to do another sketch. So here's my paper, and I need to rotate the paper 90 degrees counterclockwise. And it looks like this. So I'm going to take my scratch paper and make a sketch. So in my little post-it note, I sketched what that looks like. So this is what the triangle will look like rotated 90 degrees counterclockwise. I can use the sketch to help me draw in what these different points should look like on the image. So I know that J is over this way, straight across from L, and I'm just going to quick count. So from L to J is 1, 2, 3, 4, 5 units. So I need to go 1, 2, 3, 4, 5 units over here to plot point J prime. And then I need to go up to get to K. So I'm going from J to K. I noticed that in the original figure, that's a distance of 3 units. So I need to go up 3 from J prime to K prime. Use your ruler to draw in the lines, and now we have our image. Okay, it's your turn to practice. We've got triangle QRS, plot that. Then you're going to rotate it QRS, you're going to rotate that 90 degrees counterclockwise about the origin. Then you're going to do a second transformation, still to the original triangle QRS. Rotate that triangle 180 degrees about vertex S. Pause the video and then unpause it to see the answers revealed. There is triangle QRS. Here is our 90 degree counterclockwise rotation to get the first image, Q prime, R prime, S prime. And our second transformation, taking the original triangle QRS and rotating it 180 degrees about vertex S. So notice that S got stuck like with a push pin and it was rotated 180 degrees. Your assignment is page 489, numbers 10 through 16. If you got a sneak preview of this assignment, it was longer. If you logged in early Monday and looked at our agenda items, you might have seen it from Team 7-1. Other teams maybe, I'm not sure, but the assignment is just 10 through 16. Take your time with it, ask us questions, come to Extra Help, and do a little practice. See you soon.